morning, everyone. I did a bit of research just to find out what time is it, whether I should say good morning or good afternoon. Thanks to Corey. I was supposed to present at 11:30, which was morning, but it's still within the morning slot. And thanks, Corey, again for hyping me up with that bang. So we do sell explosives and we do create bangs, but ideally that's not the kind of bang we want to see in the blasting area. Earlier on, Eugene mentioned that there's different names that we are called by. Some people call us EaenX, ENAEX, ANEX. So we are forgiving if you call us EaenX, ENAEX, and ANEX, right? But if you call us Sasso Nitro, we're not so forgiving. So I am from the sales and technical department in the Mpumalanga and KZN area. My name is Nonkululeko Hope Dire, and I am from ENAEX Africa. So as I mentioned, I am from the sales and technical, so the structure of my presentation will cover the sales and marketing aspect first before I get to the technical, which is the case study that looks into our bulk explosives, aligned with our title, which says built for depth, designed for results. So ENAEX Africa, ENAEX actually means stronger bonds, right? That is our slogan, and it's the meaning of ENAEX. So ENAEX Africa produces and distributes a wide variety of explosives and value-added solutions. I am emphasizing on the added value solutions because we're not just an explosive supplier, but we also offer technical services, and we like to position us beyond just being an explosive supplier. So we provide a wide range of products such as bulk explosives, cartridges, accessories, boosters, electronic detonators, blasting consumables, which I will also share a bit in the next slides. And we are in basically within the mining industry, both open cast and underground, civil blasting, and the quarry space. We definitely don't supply to Zamazamas, and we don't do mine husks. So please don't call us for those. Just to emphasize on our value-added offering, right? We've got ENAEX Bright, which is a QA/QC, blast optimization and digital integration platform. Earlier on, Corey and I think our speaker from UNISA touched on the importance of QA/QC in the type of sensitive environments we are blasting in. So ENAEX has that offering. We've got OPID surface, so ENAEX just acquired OPID blast. What we've realized is that in the industry, people actually know OPID blast, but they don't know that it actually belongs to ENAEX. We also have Devitronics, which is our electronic offering, and we've got drone offering through our partners. Some of our partners are actually here that assist us in this space. And we own Riplock. I think you know it as Riplock. But it's actually MTI. So those blasting consumables that you're buying, they actually belong to ENAEX. Just wanted to share those insights because we realized that the industry doesn't associate us with these products, but it's actually under our portfolio. So regarding the title, which was built for depth, designed for results, I thought it was fitting to use one of our mines, or rather this mine is now on care and maintenance, but it's the best example to emphasize on the fact that our explosives, or that our bulk explosive range, can break rock beyond, right? I think I can safely say that we have been the most brave ones to take on this challenge, to mine deep, as deeper as plus 50 meters, and this was a great example or a case study that fitted the emphasis on our bulk explosives. Okay, so Isibonelo is, as I mentioned, it's currently on care and maintenance. It is situated in Secunda. It is a coal mine under the Tungela Group. In terms of what we used to supply at the mine, right, we used to supply Vertex A. So there is actually a range within our like it's a Vertex A range. It's not just one bulk explosives, which I'm going to touch on the next slide, because I want to emphasize that we've got a wide range of bulk explosives that we offer to our customers based on their needs. But in this case, we're using Vertex AD for the specific mine. We also supplied Explogels, Trojan boosters, E-cord, blasting consumables. Like I mentioned, Replock is actually under our portfolio. So, the way we positioned ourselves as ENAEX is that we want to offer you the full solution, right? That you don't have to buy bits and pieces in different companies, but you get the whole full blasting complement within one company. Okay, in terms of our Vertex A range, we've got our Vertex A, which is a blend product. Within that range, we've got Vertex A65D, which is more suited for the deep holes, relating to the case study that I'm going to share now for Isibonelo. And then, but we've got also Vertex A970, Vertex A980, and then Vertex A970 HR. We also have Emulgix A, which works best within your shallow holes, mainly in our quarry spaces, for cold blasts and pre-split blasts. So there is differences in terms of these products and the energy they emit. So how we position ourselves is that we don't offer a product that just like a one-size-fits-all product. We've got a whole range that caters to whatever blasting needs you have. What was also emphasized in the previous from the previous speaker was the importance of managing air blast, ground vibration. So what we realized is that some of our customers or even potential customers, they tend to use product with so much energy that they don't even need. So that's why we've got a wide range of products. There is differentiation factors in terms of the relative bulk weights, the relative bulk strength and the relative weight strength. But yeah, so this is just an overall, just for you to understand that we do offer different bulk explosives range. With the case study, I am going to focus on the Vertex A965D that we supplied as Isibonelo. Okay, this is just, we've done so many blasts there for years. We've supplied, even back then when we were still Sasol Nitro, we were supplying Isibonelo. But this is just one of the blasts that I thought we should share to emphasize the fact that our explosives works beyond, like they break ground. So this is just a block, one of the blocks that I've chosen as a case study. We're using all our products that I mentioned earlier on, our boosters, the bulk product, and the hole diameter was 271. That was the most common one used, but they did have a different one at the mine. But 271 was the most common hole diameter, and the depths would go more than 50 meters deep. So this is just an overview picture just to give you a feel of how big these blasts were. And yeah, the number of holes we had to pump. I mean, one hole could easily just take 3 tons of explosives, right? That's how deep and how large the holes were. So these types of environment require a lot of collaboration, both from the customer and from the explosive supplier, right? In terms of blast designs, quality controls, and of course from the team that needs to execute. My colleague here, I saw my colleague here from Blast Logic is also here. We also used to collaborate a lot with Blast Logic in terms of capturing data and actually monitoring if the teams on the ground are doing the right thing. But yeah, this is just a block. This is a block. This was a block before the blast went off. Where they've circled is just showing some areas where there were a bit of issues in terms of, from the previous blast. But in general, this block was fairly drilled very well in terms of bedding and spacing. With the next slide, so this is part of the audit, part of the work we do when we do blast audits. We survey our blast, we check the holes. This is part of the value-added service that we offer. But in this case, we needed to do a comparison because we have blast logic data, we've got drilling depths, and we have our people also measuring the hole depths just to compare and make sure that by the time our trucks get on the block and they have to charge those holes, they actually reference the correct depths. So this is just, a general setup. There is areas where there would be deviations. I think it's normal to most operations. We try to avoid them as best as we can. But we still work around some of the deviations or alert in advance if we still have time to do that. Borehole, on this case, we do a lot of borehole calipering. So in this block specifically, we did borehole calipering. You will realize I mentioned that these are quite deep and large diameter holes. So meaning even drilling those holes is a hassle, right? Is a challenge, and also considering the different lithology. So what you will see is. So there's certain parts, I'll show you in the next slides when I show the results. There's certain parts of the hole where you will see spikes, where your hole starts expanding, and that's mainly around the area where they had like a thin coal seam that they were not mining, but that was expected because where the rock is much more softer when you drill, then it tends to expand there. So these are some of the results that we got from the specific blast. As you can see, so where there were spikes, that's where the coal seam, basically one that they are not mining is like a waste. It was considered waste. That's where it was opening up. But in general, they were not getting so much of the deviations besides that area. And yeah, this also reflects the same. And then, so what we also did a lot there, considering that it's very deep holes, it's sensitive environments. So we also did a lot of studies on VODs. In the slides where I shared our bulk product range, you'll see that our VODs range from 4,000 to about 5.8 or so. So these were very good results in terms of VODs. We got, in this case, in the specific blast, we got 5,590 meters per second. It is very difficult to get such results in these setups because there's also quite a lot of water in some of these holes. So when we get VODs, it was definitely a celebration within the organization. And then, so this is just a video as the blast was going off. As I mentioned, that we do love a bang, but we don't want that bang that Corey showed earlier. So we want it to be very subtle, and we do analysis and see where we can improve in the next blasts. And so forth, and also ideally we don't want things like venting, because we want to contain as much energy as possible. They were using a drag line, so you don't want to also affect efficiencies of the drag line. You want to be able to break rock to size that is manageable for the drag line. But this is just to show some of the spots where there were a bit of blowouts because of some of the maybe some of the quality issues that are identified during the preparation and so forth. But in general, the blasts would go off very well, and this is a result of the specific blast. There is, on the one corner, there were a bit of softs, that's why you're not seeing your press plate so well in the one corner, but the rest of the wall, the press plates came out, like, you could see the barrels of the press plate, and there was very good fragmentation. So we tried to minimize having back break or what do you call this, excessive rock along your free faces, because we're dealing with very high walls, right, for the safety of the people and equipment. So it is very important that, in terms of these blasts, we keep them as precise, and quality is kept up to standard, and everyone plays their part that they need to play. But in general, this is just an emphasis that our bulk products, they are built for depth and designed for results. This is also some of the results as we're improving, because we had to change a lot of the designs to get this very nice, smooth, high walls with the barrels being definite. And that worked very well with the collaboration of our customer, Tungela. We had a drain and blast specialist there, Frikifori, who used to work very closely with us, and our engineers from ENAEX that used to collaborate, and of course some of our partners, like I mentioned, Blast Logic, that also used to play a role in making sure that we get these good results. But I can safely say that, if our bulk product can break plus 50 meters, it can sure break any rock in any quarry, which is what, less than 20 or so. So we definitely are built for depth and designed for results. Thank you. Yeah.